in various topics that you will be tested. Now we are going to cover topics like discriminant, binomial expansion. We'll cover that, transformation of functions. We look at radian measure, trigonometry, sequence and series, circle geometry. We shall look at it also improper integrals. We shall look at rate of connectedness, and also we shall look at differentiation and integration, which also will be involving converting a gradient function to get a curve, with how to find the gradient, how to find the turning point, stationary point. All those we are going to have a detailed discussions on how you are supposed to handle such kind of questions. So don't skip any part of this video so that you can be able to get the best of it. So let us now dive in, look at the first topic that we're going to look at. And the first topic actually here is coming from discriminant, and I believe you've done that such kind of a topic before. You are told, you may be able to be given a question that looks like this, whereby you are told that express 4x squared minus 24x plus p in the form a into x plus b squared plus c, where a and b are integers, and c, where a, b and c are integers, and c is to be given in terms of the constant p. So the first thing that we need to do here, I'll need to write this equation the way it was, and I will start by writing the equation the way it was, and I will group the first two so that I can be able to factor 4 out. Now once I've factored 4 out, you can see now I'll be having 4 into x squared minus 4x, 4 into x squared minus 6x plus p. And at this particular point now you can see I'm going to complete the square inside the bracket, and I'll take a half of the number 6 that we have there. Then I'll subtract this 3, I'll subtract it out and square it. Anytime you are doing completing the square, remember if you expand x minus 3, you are going to get positive 9 at the end, and yet it wasn't inside that bracket where we are having x squared minus 6x. So this means you have to subtract that so that you can be able to retain the information the way it was. So if we try to open the bracket, in this case we'll be having 9, 4 is going to affect these two terms, and then we're going to have negative 36 plus p. I'll be happy by writing 4 into x minus 3x squared, and then I'll say p minus 36. So this is the form that was expected, so that you can be able to get a whooping 4 marks in your P1 paper tomorrow. So if you're going to do that exam, let me also take this opportunity so that I can be able to wish you good luck, and I wish you the best. Now moving to the next part, that is part B. In part B, you are told hence otherwise find the set of values for p for which 4x squared minus 24x plus p equals to 0 has no roots. Remember, when you are told that a quadratic has no root, it means the discriminant is actually less than 0. So you need to remember that when you are given a question and you are told it has no root, it means the discriminant is less than 0. But if you are told that it has 2 distinct roots, it means you are going to say the discriminant is greater than 0. But if you are told it has 1 repeated root, at that given point you are going to say the discriminant is going to be equal to 0. But on this particular question, we are going to equate the discriminant equal to 0 in order to earn our marks. All right, now the formula for finding discriminant is given there. D equals to b squared minus 4ac, and then we can be able to identify what is our a and what's our b and what our c in this particular part. This is our a, this part is our b, and this part is our c. So you see now we have substituted, and upon substitution, this is what we are able to get. So if I take 576 on the other side, you can see now I'm having my answer being p is greater than 36. Now something that you need to remember is that when you divide both sides by a negative number, you are going to change the sign of the inequality. All right. Moving to question number 2. This is a question that we are going to look on the concept to do with binomial expansion. Under binomial expansion, you are going to do a situation whereby you are going to use combination, whereby you have 2 plus 3x. So this kind of binomial expansion, you need to use combination. But if you are having 1 plus x, you are going to use the binomial theorem, whereby you're going to use factorials. So we're going to see that in the next part of the question. So looking into this, so we're going to start by saying that this can be written as 2 raised to power 4. The power 4 is given there. So the first term, which is 2, is going to be raised to the power that is given. And then the powers of 2 are going to decrease. Are going to decrease as the powers of 3x are going to be increasing. So we're going to have 4 combination 1, 2 raised to power 3, then 3 raised to power 1. Then we're going to say plus 4 combination 2, 3 raised to power 2 raised to power 2, and then we have 3x raised to power 2. So since we are finding the first 3 terms, we need to stop here so that we can be able to simplify whatever we have here. So we can be able to put this in a calculator. 2 raised to power 4 is 16. 4 combination 1, if I put this in my calculator, I'm getting my answer being, then I need also to multiply by this 8, and 4 combination 2 is 6 times 4, then times 9 raised to power 2. So this is going to simplify to 16 plus 96, then plus 216 x squared. So this is the first part of the question. And since you are supposed to find the coefficient of x squared in the expansion here, but you see we have already expanded 2 plus 3x raised to power 4. But we are having 1 minus 2x raised to power 5, which has not been expanded. So meaning we are going to first work out this particular part so that we know what is the expansion of this. And this is the part now I told you you are going to use this is the part you are going to use factorials. Yeah, this is now the binomial theorem, see here. So which means that if you're having 1 plus x raised to power n equals for you to expand this, we're going to say is 1 plus, the first term will be 1, then the second term will be n. N is the power times the value of x, the x part, and then the third term is going to be n into n minus 1 over 2 factorial times x squared, right? And the next term will be n into n minus 1 into n minus 2 over 3 factorial times x raised to power 3. So this is how you use this particular formula. Now let's see how can you use that formula in order to expand 1 minus 2x raised to power 5. In order to do this, we are going to identify what our x is. Our x is actually negative 2x. So this is the part we're going to substitute where we have this x here, and then our n is actually power 5. Then now if we start substituting into our formula there, this is going to reduce to that, and then we need also to have let's just stop there, because we are going to be having the coefficient of x squared. This is enough because already we have negative 2, that is x raised to power 2. So if it's going to be multiplied by the first expansion that we had obtained, we can be able to get x squared. So if we simplify this, we're going to get 1 minus 10x, then plus 40 plus 40. Yeah, this is going to translate to actually 40. Yeah, right. Let me confirm using a calculator. Yeah, this becomes 40x squared. Now, because we are expanding this, we are going to multiply the two expansions together. So we are going to write the expression the way they were first, so that we can be able to multiply the two. Right, let me just copy them so that we can be able to do the expansion of the two. So we shall copy the first part. Yeah, this was actually this. And then multiply to the second part that we obtained, plus 40x squared, like that. All right, so once we have this, we are going to multiply the terms that are going to give us a coefficient, the terms that are going to give us x squared. So let us see, we are going to get x squared. So this term here and this will give us x squared. So this is going to be 216 x squared, terms that will give us coefficient of x squared. So we're going to say this part is going to be 216x squared plus this 96x multiplied to 10x is going to give us x squared. So we're going to take that, and that's going to be a negative number, right? And 16 times this one is going to give us x squared. So we are going to take this number as well now, but this is going to be a positive value. And then now, if we try to work this out, we're going to get our answer as such. Then now, since it's negative 104 x squared, which means we are going to pick the number in front of x squared, which is the coefficient that we were being asked. Right, so that's what you are supposed to do. So this question is helping you to remember how to use those two formulas, and because tomorrow you must be tested on binomial expansion, there must be a question on that. Moving into functions, and here you are told that f of x equals to x squared minus 4x plus 3, where x is greater than c. G of x equals to 1 over x plus 1, where x is greater than negative 1. Then we are supposed to express f of x in the form x minus a squared plus b. Now this one, we have already done a question similar to this. So this is just a walk in the park. You are going to group these two factor, then divide by 2 in order to get 2, and then complete the square like that. Already remember, we had said from the previous question that this number that is inside the square, this is x minus 2, this 2 that is inside where we have squared, you have to subtract the square of that number outside, because if you square this part x minus 2, you are going to get positive 4. So to cancel that effect, we must, it's a must that you have to subtract, even if the number was a positive or a negative. At that point, you must subtract. So simplifying this, we're going to get f of x equals to x minus 2 squared, and this is going to translate to negative 1 at that given point. So we have a function, and it's given that f is a one-to-one function. So we are supposed to state the smallest possible value of c. Now, using this function that we have completed above, we can be able to get the turning point. The turning point, or the minimum point of this graph, or of this curve. So once we identify the turning point, we can now be able to state what is the least possible value of c. All right. So let's continue. All right, so what I'm going to do at this given point, from the function that we had completed above, I'm going to pick the minimum point. And remember, for you to pick the minimum point, you only look at inside the bracket, you pick the opposite sign, and the number outside, you pick it the way it is. So that is the turning point. So if you are going to be given questions whereby you are expected to state the turning point, the maximum point or the minimum point of a function, and you have completed like that. You need to pick one number that is representing the x. Okay, now since we are told that x must be greater than -1, so the minimum point is going to be c, which is going to be x is greater than 2. So our minimum value of c is actually going to be equal to 2. Now we move to the next bit of the question. Here we are told that given that c equals to 5, so the domain of f of x is going to be what? Going to be x is greater than 5. So which means in order to get the range for f of x, we are going to substitute whatever that we are given as the value of x in order to get the range for f of x. Now this is the 5 that we are being told. So can we be able to get what the range of f of x is? So f of x equals to x minus 2, and then this is actually squared minus 1. So for us to get the range for f of x at that particular domain of x is greater than 5, when we substitute that, we are going to get the value equal to 8. So our range for the function is actually 8. And that will mean that if the range of this function is 8, then when you find the inverse of the function, the range becomes the domain of the inverse function. So you can now say range of f of x becomes, of course, the domain of the inverse function. Therefore, the domain of the inverse function is going to be 8. So the next part that we want to do here is to work out the inverse of the function f of x. So first we were given this, and we have already completed the square. So you are going to change f of x to y, and next you are going to switch the values of x and y, and then you try as much as possible to make y the subject of the formula, and then you can now see we are going to have our inverse function, and then we're going to decide which one is going to be the correct sign here, because we were told that c equals to 5, so the domain is x is greater than 5, so meaning that we are going to substitute into this particular part, and it will mean that the sign we're going to use is a positive sign, so that we have a positive value. Find an expression for g f of x and state the range. Find an expression for g f of x and state the range. So anywhere we have x in the function g, we are going to substitute x squared minus 4x plus 3, which is going to be all right. So if we open the bracket and put the like terms together, we're going to have x squared minus 4x, then plus 4, which is going to factorize. Of course, we can be able to factorize the denominator so that we can be able to express it as a difference of two squares. Is going to be like that. So given this function here, we can be able to graph and show how that graph looks like. This graph is a positive kind of graph, meaning it cannot go below 0. Yeah. So because we were supposed to set the range of f of x, but remember we were given the value of x being a value of c being equal to 5. So if you substitute 5 here, we are going to get the corresponding value of y. So which means that the range of f of x is going to be within 0 and 1 over 9. So this is going to be the domain of f of x. We are going to substitute 5 into that. So if we substitute the domain of f of x, we are able to get the range of f of x. Domain of f of x we were given as 5. Then if we substitute it into gf of x, you are going to get the range of gf of x. So the range in that case, if you substitute, you are going to get 0. This is actually, let me see here. So the range of gf of x is going to be what? If we substitute here, we are going to have from 0 all the way to 1 over 9. Yes. Because if you can look at this function as the value of x increases to the right from 5, the graph keep on decreasing as it's approaching 0. But this graph is never going to touch the x-axis. So that's why we're saying the range of gf of x is going to be greater than 0 and less than 1 over 9. Moving to the next question, we are told that the equation of a curve is y equals to 2x squared plus k x plus k minus 1, where k is a constant. Given that line y equals to 2x plus 3 is a tangent to the curve, find the value of k. Find the value of k. So from this equation that we are told that y equals to that, we need to equate these two equations, equating the two equations so that we can be able to find the discriminant. And in this case, if you equate the equation, put the like terms together, and since the line is a tangent to the curve, it means that the discriminant is going to be equal to 0. Yeah. So since it's touching at one exact point, we are going to have one repeated root. Yeah. So this is because this curve is going to touch the tangent is going to touch the curve at specifically one particular point. So going as per that, we are going to say the discriminant therefore is going to be equal to 0. So if you are going to be given a question to do with a curve intersecting with another line, if it's a tangent, you are going to take the discriminant 0. But if they are meeting at two distinct points, we are going to say greater than 0. But if they are not touching, there is no solution, the discriminant is going to be less than 0. So now looking into this, let me just move a little bit so that I can have enough space to write. I can be able to write the formula for discriminant is that substituting what I have so that I can be able to simplify. I'm going to be having k squared minus 4k plus 4, and that is going to be 8 into k minus 4. Then now putting the like terms together, can see we are going to have k squared minus 12k plus 36 equals to 0. Solving this, we are going to get what? We are going to get the value of k to be equal to 6. Only one value. The value of k is 6. Now, given that k equals to 2, express the equation in the form. Surely, these questions, we have done this kind of question enough. So I don't believe we are going really to dwell much explaining this one. So you're going to factor out what's common and then try to complete the square inside the bracket, right? Then remember to subtract the square of a half, and then we shall say plus 1. Simplifying, we end up having this kind of an equation, and from here we are supposed to state the coordinates of the vertex of the curve. Coordinates are gotten from that completed part, so you are going to pick a half. You are going to pick negative a half, because inside the bracket we have a positive, so you are going to pick negative, but outside we have positive a half. You are going to take it the way it is, like that. All right, now moving to radian measure, and here one of the important formula that you must know is the formula of finding arc length, and arc length in terms of radians. So this is going to be theta r. Area of a sector is going to be a half theta r squared. So once you know that, we can now be able to go straight into the question and get to see what we were expected to do at this given point. The diagram shows a sector CAB, which is part of a circle with the center C, and the circle with its center O. We are told that the radius R lies within the sector and touches it at D, E, and F, where COD is the straight line and angle ACD is theta radians. Now we are supposed to find CD in terms of R and sine theta. CD, you can see from C to D, we are having the length CO, then OD. But for us to find CD, first we need to find CO using the triangle that we have at that given particular point. So using triangle OFC, this is a right angle triangle. We are going to use it to find the length of OC. But we can now say that sine theta equals to opposite over hypotenuse. So our opposite is R and our hypotenuse is actually OC. Now we can make OC the subject of the formula and have our OC to be sine R over sine theta. But CD is actually OC plus the radius of that circle. So we are going to, let me just move this down here so that we can be able to have it there. And then now I can be able to say that CD is OC plus R because of that radius there. And if I can be able to add that, I'm going to say I can write it in the form of this, or I can also express it in this other form like that. All right, so this is how to find the arc length, rather the distance of CD. Now we need to find the perimeter of a sector. You are going to be tested on how to find perimeter of a sector. Remember, you need to know how to find arc length, and the perimeter is actually distance or round. Okay, in order to find the perimeter, we are going to use this formula, and we shall find now we are going to find the arc length, and this is going to be, remember, CD is equals to that, yeah. Now substituting the value R equals to 4, and the angle now here we're going to lose 1 over 6 pi times 2, yes, times, okay, arc length equals to the radius times the angle in radians. So the radius now in that case is going to be what? Let's just go back to the diagram and get to see what we have there. Okay, we're supposed to find the perimeter of CAB, the perimeter of CAB. So first, for us to find the perimeter of CAB, we need to find the arc length ADB. The arc length ADB is going to be given by theta r or r theta. The radius is the distance CD, the one that we had obtained, and the angle that we're going to use is also given down there. So we are going to say this is going to be arc length is going to be equal arc length of this arc length. We're going to say that's going to be equivalent to r theta, and that's theta also we are given, but our radius is that length. So CD was given as r plus, we have shown this, that CD equals to r plus r over sine theta, but now we are told r equals to 4, so we can be able to substitute 4 in this part so that we can be able to use it as a radius at this given point, right? Then we are going now to multiply this radius by the angle, and the angle is going to be 1 over 6 times 2, 1 over 6 pi times 2, which is going to be 1 over 3 pi. All right, if you simplify this, we're going to get our answer as 4 pi as the arc length. But remember, if you are finding perimeter, perimeter is distance all round, so we are going to add 12 plus 4 pi, which is going to translate to 24 plus 4 pi. Next part, we are supposed to find the area of the shaded part. Now, in order to find the area of the shaded part, I'm going to consider the triangle OFC. Then I'll use that triangle. I work out the area of that triangle, right angle triangle there, OFC. Then I will subtract the area of the sector where we have the center O, right? So this sector of the circle, part of the circle, so meaning we need to find what the angle that we are having at F or C. But since we know what the angle theta is, we can be able to find angle F or C, which will be used in the process of working out this question. So let us go and extrapolate that so that we can be able to show what was expected to do in this part. Let me draw that triangle there. So if I draw this triangle, I'll have 90 there, and then I'll have my radius 4 at that given point. So I can be able to find the height of this triangle, because I'm going to use a half base times height. So I can be able to use the angle and the opposite side, which is 4, in order to find the height of this triangle, so which I can call x. So our x is going to be actually 4 over 10, 1 over 6 pi. So if you work out this, you are going to get your answer as 4 root 3. And because we are supposed to give the area of the shaded part in terms of pi and root 3. So I can be able to draw that sector there. So we are finding the shaded area of the upper part. But now I need to find the unshaded part of the sector here, but of which I need to find the area of the triangle first. So the area of the triangle is going to be a half base times height, and the height value of x, we had gotten it to be 4 root 3 times 4, and working out that we're going to get 8 root 3. Next, we need to know what is this angle down here, and of course that angle is actually a third. So I can be able to find the area of that sector. Yeah, so if we multiply, we are going to get what? Our final answer becomes, let me just use my calculator and check, 8 over 3 pi. Now, in order to get the area of the shaded part, we are going to subtract the 2. Once you have subtracted the 2, then we shall multiply the 2 in order to get, because we had originally the shaded area that we are working out, we are having two right angled triangle, that is triangle FOC and triangle OEC. So meaning if I've gotten the shaded area of one of the triangle, to get the area of the other one, I need to multiply by 2. Okay, so this is the area of the part that we have worked out. So what I did, I found the area of the sector minus the area of the right angled triangle in order to work it out. And if you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload new tutorials, you'll be notified. All right, moving to the next part. I worked out the area of the triangle, then I worked out the area of the yellow part, the one that I've dotted yellow, then subtracted that area from the area of the right angle triangle, then times 2 will give us the area of the green shaded part, the original part that was shaded here, this part there. Okay, and that's what we are supposed to do. In question number 6, over a 21-day period, an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometers. On the first day, she runs 13 kilometers. Find the distance she runs on the last day of the 21-day period. This is actually arithmetic series, and 2.1 is the common difference, 13 is the first term. Now, in order to work out the 21st term, that is the nth term, we are going to use the formula a into n minus 1 into d. So this will mean that we can be able to substitute the first term 13 plus 21, which is the nth term, term number n, then we multiply to 1.2. that is going to give us what? If we work it out, we are going to get our answer as 37 kilometers. So this means that you must know how to use the arithmetic series formulas, that is nth term and also the sum of n terms, as we're going to see also how to find the sum of sum to infinity for geometric progression. So find the total distance she runs in the 21 days period. So in the 21-day period, in order to get the sum of all the total distance covered, we are going to find the sum of all the distances. And we are going to use the formula nth term. So A represent the first term. I needed to identify that. D represent the common difference, and n represent the number of terms. Now we can be able to move to the second part, where you're going to use sum formula, and that's going to be n over 2 into 2a n minus 1 into d, and then substituting everything that we have there, we can be able to work it out. And in the process of putting this in our calculator, let's see what we are able to see. This is going to translate to 525 kilometers. Now, the second and the third terms of a geometric progression, first, second, and the third term of a geometric progression are x, x minus 3, x minus 5 respectively. Find the value of x. We know in order to find the common difference, we take the number in front divided by the number below. That is finding the common ratio. Finding the common ratio, you take the number in front of the sequence, divide the number behind it. So we're going to form an equation like that, which we are going to solve, and that will enable us know the value of x. Now, once we know the value of x by putting the like terms together and solving the quadratic equation, we can be able to go ahead. Yeah, this quadratic equation actually is going to cancel out, and then we are going to have our x equals to 9. Then substituting into the terms that we are given, we can be able to know the common ratio and the first term. So we know that x is 9 minus 3, that becomes 6 over 9. And if you can simplify, you are going to get actually 2 over 3 as the common ratio. So we are supposed to find the fourth term of the progression, fourth term. So fourth term of the progression, that is going to be a r n minus 1. And remember, this is now arithmetic progression. So the nth term is given by this formula. Substituting a is the first term, which is actually 9. A is our first term, which is 9. And the common ratio is 2 over 3 raised to power 4 minus 1. And that is going to translate to, working out this, we're going to get 8 over 3. All right, which we can be able to write as 2.67. Now, sum to infinity is another area that you need to remind yourself. So the formula for sum to infinity is this. So first term over 1 minus the common ratio. And this sequence must be converging for you to work out the sum to infinity. So otherwise, the formula to use for them to give you a question to do sum to infinity, they must give you a progression that is converging. So basically, what you need to know is how to use the formula and what comes where. And our final answer now becomes that. Right, moving to circle geometry, circles, and the geometry of circles. Let's see what question are we expecting at that given point. We are told that a circle has a center at the point B 5 1 and the point A -1 -2 lies on the circle. Find the equation of the circle. So the first thing that we're going to do here, we need to find the radius of the circle. And the radius of a circle is obtained by finding the magnitude between B and A. We try to find the magnitude AB. So we were given the center there, and then we have a point on the circle, which is actually A here. So radius is going to be like that. So this is this is how we find the radius. When you are given two coordinates, you take one coordinate of x minus the other one, square that. That is x1 minus, that is x2 minus x1 squared, y2 minus y1 squared. Then you find the square root in order to work out the magnitude. And if you simplify this, you are going to get this is actually 45, which is going to translate to 3 root 5. Now, since we know the center, we can be able to use the standard equation formula of a circle and then substitute what we know. A and B are the coordinates of the center and R is the radius. So we are going to substitute the centers there, because the value of x was 5, so it's x minus 5 squared plus y minus 1 squared equals to 3 root 5 squared. So if we can square on the other side, we end up having this equation, and we can say equals to 45. All right, the next part here, we are told that point C is such that AC is the diameter of the circle, point D has a coordinate 5, 16, and then show that DC is a tangent to the circle. Something that we need to remember for a tangent to the circle is that a diameter or the radius meet the tangent at 90 degrees. So if we know the structure, the strategy I'm going to use in order to work out this question, I'm going to work out the gradient of the tangent. No, I'll start with the gradient of the diameter, and then I'll find the coordinate where the tangent and the circle meet, and thereafter I'll find the gradient of the line DC, and check if I multiply the two gradients, can I get -1? Because if two lines are perpendicular, then gradient the product of their gradient will give us -1. So that's why I'm saying, in order to work out this question, I'll start by working out the gradient of AC, which is the diameter. I can even say CB. I can work out the gradient of CB or AC, and then I'll work out the coordinate where that line DC rests on the circle. Once I have that coordinate, then I'll use the coordinates of D in order to work out the gradient. Then once I have the two gradients, I multiply them to check if they are giving me -1. So if they are giving me -1, it will mean that now that's the tangent. So we have the general coordinate C, X, Y. You can see now we can be able to find the gradient of the diameter using A and B. Yeah, we can be able to find that. Gradient of AB will be the gradient of that diameter. So remember, gradient of a line is actually change in y over change in x. That's y2 minus y1 over x2 over x1. I can be able to substitute the values there so that I can be able to get my beautiful gradient as a half. Then I need to find the coordinates of x and y. I'll use the midpoint formula because I know if I use the midpoint formula, it will mean that remember, if I take midpoint x1 plus x2 over 2, y1, y2 over 2, right, like that. So I'm going to use this knowledge in order to find what my x is and what my y is. And definitely, if I equate the x plus minus 1 over 2 equal to 5, I'll be able to find that value of x at that point, like this. Similarly, I'll do the same. Let me just move this a little bit here so that I can have enough space. do the same to y, and I'll get my value of y as 4. So the coordinate of point C is actually 11, 4, and then now I can be able to find the gradient of that line. You see there the gradient is -2. Things are shaping up. If you multiply m1 and m2, you get -1. Let's check. Yeah, a half times -2, you are going to getting a -1. Then perfect. And since the coordinate C is on the circle and they are agreeing like that, I can now conclude and say that AC, DC are perpendicular, and since C is on the circle, then we can now say that there is a tangent. The diagram shows a circle there and a straight line, so intersecting at the point A and the point D on the axis, such that AD is perpendicular to the x-axis. So the point is, I want us to know how to find the coordinate when a circle intersects a straight line.